So again, we're skipping that first page. It's okay, just because yesterday's class was cut short. So some inferences that we could make if we had filled out the first page about end behavior based upon the degree. By the way, the degree is just the highest exponent. So like 2, 4, 2, 4, 3, 5. The highest exponent out of the whole thing. Those are the degrees. So if the degree is even, then those arrows point in the same direction. So like on the problem that we just did on day 23, number 9, that graph, they were both pointing down. That was because it was an even degree. It means that they both point in the same direction. They either both point down or they both point up. If it's odd degree, then they point in opposite directions. That's what that tells you. So I'm going to write that down. An even degreed, so like 2, 4, 6, 8, even, function has end behaviors going in the same direction. An odd degreed function has end behaviors going in opposite directions. So when you add up all the multiplicities of the zeros, if it's an even number, then you know they're going to point in the same direction. If it's odd, you know they're going to point in opposite directions. Then we look at something called the leading coefficient. That's the number that is in front of the variable with the degree, the highest exponent. So like looking back over here, I'm going to color code this for you. Leading coefficient, here would be at positive 2, negative 1, negative 1, positive 1, positive 1, positive 1, negative 1. You see it. It's the number that's in front of the one with the highest exponent. Now these could be, they don't have to necessarily be the very first one. If we put them in order, it is, but just know it doesn't have to be. So if the degree is even, and the leading coefficient is a positive number, then that means they both point up. So we write that this way, though, as x approaches negative infinity, so as I'm going to the left, f of x goes to infinity, goes up. And as x approaches positive infinity, f of x, again, goes up. Notice they're both the same, because it's even. If it's even and that leading coefficient is negative, then they both point down. And again, that's like number 9 on homework day 23. They were both pointing down, and remember I said, and we're going to talk about this today. And that's because that's what made that A negative, because I knew they were both pointing down. And so that leading coefficient has to be a negative number. So as x approaches negative infinity, f of x approaches negative infinity. And as x approaches infinity, f of x approaches negative infinity. It just means they're both going down. Then if the degree is odd, then I know they point in opposite directions. So if it's odd, and we'll start with positive, so the leading coefficient is positive. As x approaches negative infinity, f of x also approaches negative infinity. And as x approaches infinity, f of x approaches positive infinity. So that means if it's odd and positive, it goes like this. It goes down on the left and up on the right. And then when I flip-flop this and make it odd and negative, it's going to go this way. So as x approaches negative infinity, f of x approaches infinity. And as x approaches infinity, f of x approaches negative infinity. So the first one is degree, second one is leading coefficient. So even positive, they're both up. Even negative, they're both down. Odd positive, this one goes up and this one goes down. And then odd negative, it just flips. That's what it says, kind of like a dance thing. All right. So we're going to talk about it for here. We're going to complete this table. We have a graph. First, we're going to talk about their zeros and their multiplicity. So looking at this first graph, Cameron, give me the zeros.
I can't. I think that's -3.
Oh, here, I made it bigger. Yeah.
Okay, and -3 and 1.
-3 and 1. Very good. Multiplicity of the -3, Justin? 3. And multiplicity of the 1, Shelby?
1.
Yeah. And these are multiplicities. Oh, it was outside it, sorry. I could have. There we go. So this one has a multiplicity of 3 and of 1. So, what would the degree then be, Tyler?
It would be even.
It is even, yes. What is the actual number that's the degree?
4.
Yes. So it's a quartic. And then determine if the leading coefficient of the equation is positive or negative. Justify your conclusion, and then write a possible equation for the function. So, its degree is 4. So like you said, that is definitely even. Is the leading coefficient positive or negative, Jose? Negative, because they're both pointing down, right? So, we can say, since the degree is even, and graph points down on both sides, the leading coefficient, which I'm just going to put LC, is negative. So I know it's negative A. I'm just going to put A there because it could be whatever number. I know it was -3, so that's x plus 3, and it's cubed. And it's +1, so that makes this x minus 1, and it's to the first power because the multiplicity is 1.